one of the many applications of complex conjugates. I'll give you some of these other applications in the exercises, but for now, what I think is important is this simple one that essentially shows us how we find the quotient of two complex numbers. Quite simply, sparing you the details, if I have c plus di divided by a plus bi, I simply multiply numerator and denominator by the complex conjugate of the denominator. Okay? What will that do for me? Well, when I multiply the two factors in the numerator, I'm going to get a real part, namely AC plus BD. In other words, it's minus BDI squared, but I squared is minus 1. So I'm going to get AC plus BD. I'm going to get an imaginary part, which is AD minus BC. But the denominator will just be A squared plus B squared, which is a real number. In other words, what this tells me is I can now write the quotient of two complex numbers in the form what? A real number plus I times a real number. In fact, the only time I can't do this, I have to be careful, A or B must be unequal to 0, because if both A and B are 0, this is a 0 denominator, which I don't allow myself to divide by. And the only way both A and B can be 0 is if the complex number is 0 plus 0i, which is the number 0. So I'm saying, again, just like in the real case, I still can't divide by 0. At any rate, to give you a more practical illustration to see this with numbers, not practical, but at least concrete, 3 plus 2i divided by 4 plus I simply multiply numerator and denominator by 4 minus I. You see, what that does is, downstairs I get 4 squared, which is 16, minus I squared, which is plus 1. 16 plus 1 is 17. The real part is going to be what? Here's 12. 2i times minus I is plus 2, is 14. 8i minus 3i is 5i. So this quotient, 3 plus 2i times 4 plus I, is 14 seventeenths plus 5 seventeenths I. And by the way, as a trivial check, and you can do this if you wish for an exercise, simply take the answer that we got here, multiply it by the denominator, 4 plus I here, and actually check that that product comes out to be 3 plus 2I. At any rate, this use of complex conjugates shows us that when you divide two complex numbers, the result will be a complex number except for division by 0. You see, that's what went wrong with our integer problem, 2x equals 3. The reason that we couldn't solve it is that to solve 2x equals 3 required the process of taking the quotient of two integers, and the quotient of two integers did not have to be an integer. Notice, on the other hand, that the quotient of two real numbers is a real number as long as the denominator is not 0, and the quotient of two complex numbers is a complex number except for division by 0.